Good afternoon, everyone, and welcome to our webinar. This is Thomas Bonicel from Solarplaza. So welcome. Thanks for taking the time to attend our webinar, focusing on Nordic region and specific technologies which have value for solar energy in that region. So again, my name is Thomas Bonicel from the company Solarplaza. I'm in charge of our project that we will handle in Stockholm on September 23rd. And today, after I will have gone through a few slides of introduction, you will have a presentation from Sascha Krause-Tuenker, who's the managing director of Next to Sun, and will tell you a lot of cool information about vertical and bifacial technology. At the end of this session, you will have time for Q&A. I'll tell you a few more things about like how the session will work. Solarplaza, if you don't know who we are a Dutch company established in 2004. We are based in Rotterdam, the Netherlands, and our job is to promote the development of solar energy by organizing events, so either physical or virtual. We have begun, thanks or due to Corona, to organize a number of fully virtual events those past few months. We also do trade missions. And so far, we've had like a portfolio of close to 150 events in more than 40 countries. And our key strength is our network of solar PV professionals, where we have more than 60,000 people in our network. So events. A few events we'll be doing in the next few weeks and months. Of course, the Solar Future Nordics on September 23rd in Stockholm. I'll tell you a bit more about that in the next slide, but a few others to just like show our different markets and show you some interesting things in order of time. And we have more events, of course. Check all of them on solarplaza.com. But an event that can be interesting for you is the one focusing on Portugal. It's going to be actually a fully virtual event because the situation in Lisbon is not really like to our liking in terms of health and safety for our attendees. So we've decided to go fully virtual for Solar Market Parity Portugal on September 15th. But then the following events that you see on this page are still going to happen physically. One in Paris on October 6th, where we've got a really cool venue booked on the Champs-Élysées with tons of space to be able to be in line with social distancing and still enjoy a nice networking event. We will do our second edition of Floating Solar on the 4th of November in Amsterdam. And we will be our key event for the year in Europe, Solar Asset Management Europe on November 11th and 12th in Frankfurt. Few more words on the event, which is the key focus for today, Nordics. So Solar Future Nordics. It will take place on September 23rd in Stockholm at a very big venue called the Waterfront Center, very close to the main train station in Stockholm. We have also there a focus on the health and safety of all our attendees. We have plenty of space to be able to have 100+ attendees, still with social distancing and no handshake during the event. So plenty of space, very nice venue. We have a very safe health protocol organized with the Radisson. And then our expectation is to have more than 100 people from the all local regions, so from Denmark to Latvia, passing through like Norway, Finland, etc. We have also already like registrations from people in like Germany, UK, Netherlands, and like all the region around Scandinavia. We have 6 sponsors, with some of them having an exhibition at the event. And with all the tools we'll have at this physical event, you'll also be able to super easily network with people you want to meet. Very first event for us in that region, very first event also of that type in the region to connect solar professionals for Scandinavia. So again, I'll say a bit more about that at the end, but we hope you can come and join us at this date, September 23rd in Stockholm. So a few practical notes for that webinar, super quick and easy. If you have questions, technical issues, etc., you should see on the side of your screen the possibility to ask questions. So please ask your questions there. Ask your questions during the webinar, but we will do the question and answer session with Sascha at the end. So ask your questions during the flow of the presentation, if I may say, and we'll take care of that in the end. You can also see, like on your screen, the handout section, so you can already download from here the deck that Sascha will present. And later on, by the end of this week, maybe Thursday, maybe Friday, we'll see like on how quick we can manage that. But everybody registered to the webinar will get an automatic email from us with the link to access the slides as well as the recording of the webinar. So again, I hope it's clear for everyone. I'm soon going to stop with this introduction and leave the floor to Sascha. So Sascha will entertain you on like the content webinar. Sascha Krause-Tuenker, he holds a diploma in business administration from the University of Frankfurt. He's got more than 20 years of experience in various roles. He's been CFO and CEO of different companies, and he's been now with Next2Sun for a year, currently being their managing director. And you'll see, I think he will explain and teach you a lot on vertical and bifacial technologies and how they're really like a cool technology for colder countries like Scandinavia. So Sascha, the floor will soon be yours, but before we get there, Sascha, dear audience, had a poll for you. So let's launch that first poll. And if you can just take a few seconds to answer this poll. So are you already familiar with the vertical and bifacial technology? So it's either yes or no. That's going to give Sascha a feel of like how knowledgeable about, let's say, his product the audience is. So let's wait, let's say 10 more seconds and see what happens. Right now, Sascha, you have an audience which is like pretty much familiar with the technology already. Okay, we'll stop it there. So like right now, in terms of results, we have 3/4 of the audience, Sascha, who knows this technology, and a quarter who does not.
Okay,
With
great.
this said, Sascha, welcome. We're giving you the controls right now. So let's just make sure you can control your deck, and the floor will be yours.
Yeah, thanks a lot, Thomas, for the very nice introduction and the invitation. Yeah, and of course also, thank you from my side to the audience for taking time and hear a little bit about vertical bifacial technology. I will just check if the control is mine now. Yeah, looks good. So I think the first question which arises when you see the title is a question of vertical bifacial. I think bifacial is quite common, but vertical is not that common. And yeah, the first question I think arises is the question why? Why vertical? This question was already addressed in a few years ago, for example, in the Bifi workshop from Eric Gerritsen, and they had a very humoristic approach in addressing this question. I want to share with you one slide from this presentation. Vertical, bifacial, why vertical? Yes, maybe I leave the interpretation of this slide completely to the audience. My simple interpretation is maybe there are reasons why vertical could make sense. I want to show you what, from my point of view, are interesting aspects which lead to vertical bifacial PV being an interesting technology, especially if we're looking more to the northern countries as we're doing today. So I want to show you a first slide also from this Bifi workshop in 2040. And what they did was they compared where vertical PV is vertical east-west oriented PV, I have to say, is simply generates more electricity yield compared to a south-oriented tilted one. And that's, I think, the first quite interesting result, since we see all the green ones, in all the green areas, the electricity production per year and per installed capacity is at least 5% better than the south-oriented one. And what we see is that especially Northern Europe is also included in the green fields. Yeah? So simply from the overall electricity production, the vertical installation has in these regions performance, a better performance than the south-oriented one. So I wanted to give you a very short introduction. As we saw, many of you already know the system, but I will give a very short overview. Also, I have a lot of slides, more than it would be possible to see in detail within, let's say, 30 minutes. And that's the idea, that I finish after half an hour and we can move to your questions. So I will, at some slides, I will move quite fast forward. You have them in the handout. You could, of course, also ask questions, even or also after this session via email or so. So do not worry if I do not go into all the details. I think it makes sense to finish within the time and have more time for questions. So a very first look at this at such a system. This is a plant we installed in Germany. It's a 2 megawatts plant, and yeah, we see this vertical installation with, in this case, east-west orientation. And I think it's very easy to see that, for example, one of the advantages is that it takes nearly no space. Yeah? This is not it was not the only point that we have higher electricity production, but we have also the advantage that we need a very less space. And yeah, more than 90% of the field is still usable for agriculture. And as we see, as the road distances are quite huge, it's also very good to be used with to be used with conventional agricultural machinery. So from the agricultural aspects, we see some more details later, but we see that that works very well together, the PV production and the agricultural production on the same land. This one I will skip. You could have a look at it. It's only the components of the system. Let's move to the, of course, very interesting energy aspects. One we already saw. The other I will show you on the figure is the production profile. Now we see that here a comparison of a conventional plant with a vertical one, and we have a completely different production profile. The electricity production goes very steep up in the early morning hours and comes down very late in the evening. And at noon we have very low production due to the fact that the sun is directly above the vertical system at that time. What we see, what might also be interesting, is that the production isn't zero at that time, but it's about 25% of the peak production, simply from reflection from indirect irradiation. Yeah, and what we also see, we have in the gray line the electricity prices in Germany from this day. And what we see is that the electricity price fits very well to the production curve. Yeah, I would expect that it's maybe quite, it's also in the Nordic region very similar. And so we have with the system an advantage simply of the outperformance of the market values compared to conventional south-oriented plants. So another aspect which could be interesting is also not what we just saw was the optimization of the production during the day, which is a very interesting aspect. Another could be also over the year with another orientation, with the south orientation. Especially in Nordic regions, this is quite possible. And if you compare it with the south-oriented tilted one, it's a little bit less an electricity production, but the difference is not that big than as you would expect, maybe around 10%. You still have that advantage that it's vertical and need no space and all this stuff. And you would shift electricity production from the summer into the winter time. So at I think these figures are also from Germany, but here we see with a conventional south-oriented plant around 25% of the electricity production in the winter time and 75 in the summer. And if you install a vertical, a south-oriented one, you would have around 1/3 of the electricity production in wintertime and 2/3 in summer. So that might also be interesting if the prices for electricity are systematically higher in winter than in summertime. Then vertical PV also with the south orientation might make a lot of sense. Here we see this production profile, you see the differences. Then we what we can do with the system is that we can do some production profile design. Yeah, and we have here a quite interesting example from a dairy farm in Ireland, where we see that the electricity demand, this is a plant for self-consumption, and the electricity demand is quite near to what we have as a production profile from east-west orientation. So this was quite easy. We installed their east-west oriented vertical PV. But depending on whatsoever demand curve during the day, we could also combine different orientations. And as I said, we could have some kind of electricity production profile design to simply to fit the demand with the electricity production we have from such a system. Another point I want to address is from the grid integration, the grid perspective. On the one hand, if you have a lot of PV already in place, it's sometimes difficult to add even more power or even more PV into the grid, simply due to the fact that it's full. And the grid cannot handle more electricity, more PV production. That's in Germany at very many places the case. And what we see here is that the incremental peak production is very low if you add such a vertical PV, east-west oriented vertical PV to conventional, to a lot of conventional south-oriented production. You see that the peaks in the morning and the evening hours increases, especially the tails of the production curve, but the peak is more or less unchanged. It's only about 20%, 20 to 25%. That was what we already saw, what the capacity or the additional production at noon is. Yeah? And of course, this is also very interesting. If the grid is nearly full from conventional south-oriented plants, there's still a lot of space for vertical east-west oriented systems. Another fact which could also be very interesting is that you can reduce the cost of infrastructure, of the central infrastructure, by combining different orientations. Yeah, that's what we did here. In this case, a conventional one, production curve of a conventional one together with east-west oriented one, but you could also take two vertical systems with different orientation. And in this example, we see, for example, 32 megawatts. If we have a transformer station with 32 megawatts, you would expect that for a south-oriented system, that it's possible to handle around 80 megawatts peak installed capacity. The same if we are only taking vertical east-west orientation, but if we do a combination, it's more than 100, since the combined production profile simply is more continuous during the day, and so you have a lot more electricity production with only with the same transformer capacity. So that's, I think, the energy aspects. Then we can move forward to the agricultural aspects of the system. From our perspective, it's combinable with a lot of plenty of different application. We see, for example, simply conventional agricultural cultivation with a huge variety of crops, for example, potatoes, beets, carrots, all this stuff. Also low growing cereals, of course, you get in conflict if the plants grow higher than the modules, then you have issues with shadowing. So, for example, corn would not work at all, since it's I think around 3 meters, which would then you would not find any module in the field. And but for example, also with the lower growing cereals, this should work very well. We already have a lot of experience with grassland use, which is of course very easy to handle. We can do hay production. We could also have produce silage or simply animal farming. Also with cattle, we tried and it worked very well. What a very interesting fact is from what we saw from the field, from the plant in Birmingham, the 2 megawatts plant, is that we did comparison. You see, due to regulatory reasons, we have only not all the land was used for PV, and we did some test of the hay production inside the module rows and outside the field. And the very interesting result was that the production was much higher inside the module rows as on the outside the field. Yeah, and this was really also interesting for us. Okay, so I think this year was quite sunny, but obviously the crops grew better with having some shadow from the modules. And that was also interesting. We divided every row into 3 parts and measured the western one, the middle one, and the eastern one. And always the western one was had the highest production, the middle one the lowest, and the east one was in between. But still, even the middle one was better than the production of the outside the plant. And I think that's very interesting that in this case, 1 and 1 is not even 2, but 2 point something. Since we have also a positive impact from the PV on the agricultural production. Of course, this is only data from 1 year, but we're of course going forward to collect more data and get more and more experiences with it. But I think we can be quite sure that it's not a disadvantage. I think the ecological question is also very important if you wanted to install a PV plant. And I think also here we have some aspects which are quite special for a vertical system. And one point is that it's some kind of windbreaker. So we would expect a reduction in soil erosion and maybe also soil dehydration, simply due to the fact that we slow down the wind speed, and the ground might also be, I would expect very sure that this is also one of the reasons why we saw this bigger we had a higher hay production within the rows. This dehydration, we have no data available for that so far, but we see the result, and we also know that we can reduce the size of the system inside the field, since the wind speed there is much lower than in the outer spaces. Another question is, of course, the impact of such a system to the land. And what is, from our perspective, a very interesting advantage, of course, is that we have no sealing at all and nearly no overbuilding. The superstructure is less than 1% of the field, compared to 50 to 60% of other systems. And we have no changes in the water balance. And regarding the solar radiation, we only have, let's say, we pick up around 15% of the radiation, which means 85 is still left for the agricultural crops. And we see that this can also be an advantage and not a disadvantage, that we catch up a little bit of the irradiation. What also might be an interesting point for vertical installation is this structure. We saw in the picture the tractor passing by in the middle of the rows, and what we had so far, in the picture we saw a mowing system with 8.7 meters, and the row spacing was 10 meters. So a little bit more than 1 meter was left. In another plant, also with 10 meters row distance, we tried a mowing system with 9.2 meters. Yeah, so there was really more than 90% used with this machinery. But still, we have, let's say, roughly 1 meter, so around 10% left of the field, which is also without any superstructure and not influenced by the installation, but still usable as, for example, for ecological enhancements. That's what we think is a very good idea. We can create high quality structures under the module rows and, let's say, between the farming rows. and this can also be enforced by some organic materials, dead wood, or some humid areas or whatsoever, which would be a huge advantage for the diversity of flora and fauna, and of course can also help you if you develop projects with such a system, simply to also to get permission of building such an installation. So another aspect sometimes, especially we know from Germany very well, that it's also a question if you wanted to install such a system, how the impact is on, for example, the RV fauna. And what we see here is that this bird is very happy to have this system, simply as he's able to hunt from there. Of course, what's an advantage for him might be a disadvantage for the mice or whatsoever he's hunting. But especially for the RV fauna, we are quite sure that many kinds of birds would not have a disadvantage due to this fact. I think that's enough on the ecological aspects. What I also wanted to explain is that is a special use of this system, which is a solar fencing system. This is simply an integration of a vertical PV into a fencing system. Yeah, you can see here, for example, a chicken farm, which has such a fence. This is in Austria, and what we see is we simply have this combination of vertical PV and also from this fencing. So one installation for two purposes. And what we also see is that obviously also the chicken enjoys this system, simply having the shadow from the modules. At that time, all the chicken were around the shadow of the modules. Yeah, I think that's also a quite interesting application, which can make a lot of sense. So I wanted to finish with some data we collected for example, for an example 5 megawatts project. We only want to do a very rough comparison. On the one hand, we have a little bit higher prices for the modules and for the racking system. For the racking system, due to the huge wind load, which need to be handled. Yeah, so we simply need a little bit more steel compared to a south-oriented plant. And for the modules, to take the technology with a high bifaciality rate, so with a high backside efficiency, we currently use N-type PERT modules, which have around 85% backside efficiency. But we are looking forward to the heterojunction technology, where we expect more than 90%. Most already are over 90%. But yeah, this type of modules is currently still quite expensive, but we are very optimistic that this will change within the next years. We know that there will be a new huge production capacity coming to Germany. I think they will start next year with 500 megawatts and will even increase to more than a gigawatt. So this will be, I think, a very interesting technology for us. We already had modules which were more or less symmetric. So the backside efficiency was really more or less the same. There was no difference to be seen. We see a higher electricity yield. That's what we saw from the first or the second slide. we see higher electricity prices, higher market values. And yeah, on the other hand, we need a little bit more space. That's a simple fact, since we have the rows, the distance between the rows of about 10 meters. We expect around double. We need around about 2 times the size of the area. But still, as we see, we do not lose the area. It's still more or less complete, usable for agriculture and also for ecological enhancement. The land costs normally are a little bit higher still, since we normally, it's not normally not double, since the possibility to use the agricultural land, we get along with lower rents, but of course, all in all, it's a little bit higher. So we see quite a comparable yield from conventional versus vertical installations. The life cycle we would expect a little bit longer due to the glass modules we use, but I think it's, yeah, this is not the main effect. Okay, I think that now I'm finished so far. Okay, no, one slide as some sort of bringing together the key points. We see from our perspective a lot of advantages for different stakeholders. On the one hand, for the landowners, which normally also are the ones using the land for agricultural purposes. They, with such an installation, they have the opportunity to go on with the agricultural use. We see from the environmental protection the advantage that on the one hand, we do not have this trade-off between energy and food production, and we can also combine the systems with some ecological upgrading. We see that it might be interesting also for the grid operator, due to the fact that we produce electricity when it's needed, and when electricity production from conventional PV is rare. And we have a lot of degrees of freedom for designing production profiles, especially for some self-consumption installations. And the last point, the solar fencing system, I think, is also quite smart to combine fencing with the vertical PV. Yeah, I think this is all from my side. Yes, that's what yeah, I wanted to explain to you, and yeah, I'm quite interested in your questions and our discussion.
Super, thanks, Sascha. So for everybody, like you're seeing now, like there are a few backup slides. No worry, you will get all the slides again before the end of the week. So you will also see those backup slides from Sascha. Please keep on sending your questions in the question box. We already got a few there. We will take care of them in just a few seconds. But before we get to the questions, we have 2 more polls to also get a bit of direct feedback to Sascha. So let's go with the first poll. Do you have difficulties to acquire land or get building permissions? And so you've got like 3 different options. Either you can indeed have difficulties to acquire land, or you get challenges to get building permissions, or do you also have challenges to get grid access? I think it's for Sascha's perspective to understand a bit better what you guys in the field are facing as some key challenge. Let's run that for, let's say, 10 more seconds. We have a clear winner right now. So yeah, Sascha, like right now, from the people who answered this poll, 2/3 have actually challenges to get grid access. And then 22% equal for like land and building permission. So looks like in our attendance today, the grid access is the key thing. And then
okay. Interesting.
One final poll before we get to the Q&A side. Let's launch that very final poll. Perfect, it's there. Do you expect bifacial system to be helpful with your challenges? Easy question, yes or no? I think this is for Sascha to get a bit of a feel of like how helpful indeed he's convinced about his solution, but how helpful do you think it is? Let's wait 5 more seconds. Well, 86% yes, 14% no. So I mean, like Sascha, you have an audience who's convinced already. So let's see. Let's see what kind of questions we're getting. So we have definitely a few ones. To everybody, we'll try to get most of them answered. We can't promise because of time we can do everything. Again, like questions on the slides, don't worry, you will end up with the slides in your mailbox in maximum by Friday. So let's see. Let's see, I'm seeing the questions. Let's see with which one we could begin. Let's begin with this one. It was one of the very first questions. On bifacial systems, are both sides of the system equally efficient?
Okay, that's a good question. That's what I explained in the end. The backside efficiency depends mostly on the module type technology. Bifacial one works generally from both sides, but if we take the very common P-type PERC technology, it's only around 65%, which from our perspective does not fit with this kind of installation. As I said, we take currently N-type PERT, which is around 85%, has 85% backside efficiency, and is from the prices still quite economic. But heterojunction technology gives the opportunity to get backside efficiency of more than 90%. But so far it is quite a little bit more expensive, but we see the prices decrease, and we expect that next year the price will really be competitive, and so then we have backside efficiency of more or less the same as on the front side.
And a bit in relation with that, another question is like, do you use a specific module technology in those vertical installations?
Not generally. It's from the technical basic, it's the same. We use normally frameless glass module. That's where our racking system is designed for. And so this type of modules you could get from different producers. That's no problem at all. You need some other small changes like cable lengths or so, but that's not a problem to get if you wanted to install a bigger plant. So our aim is with our next to sun mounting systems, we provide in general the racking system, but for small installations we could also provide the modules. For the huge one, everybody can buy them directly from the producers.
Okay. To get to a different kind of question. So you've shown like your technology can be used as like a fencing technology, like with that picture with the chickens, but could it be used also like on the side of like noisy roads and highways as some kind of also like noise barriers?
Yes and no. In general, yes. The point is that glass works very well as a noise reflector, but it doesn't absorb a lot of noise. Yeah? So in general, it can reduce the noise behind the barrier, definitely. But as a if you really wanted to say, let's say along if it's along a highway directly, maybe through a city or so, we do not expect that it would be the noise reduction would be enough. But of course, there is an effect, and it's definitely also a possibility in, let's say, more outer areas or so, to have both fencing along the highway as well as electricity production, as well as some noise reduction.
Fair. But interesting, and maybe like new technologies later on will come to make this kind of installation like more like soundproof. Who knows? So I'll merge two different questions in one now. Like in terms of the racking system. So at one point in time during the presentation, you said this is not a great technology when you have corn because corn is high, but well, isn't a solution to just make like even higher racks? And then together, like same question together with that, but then like with racking systems, especially in the winter, so you create more shadow in the Nordic region. Doesn't it actually contribute to like also like getting a colder ground and having in fact a bit of a negative effect?
Okay, yeah, I will try to separate the answers. On the one hand, higher racking is a higher racking system for corn is not very easy to handle, since the key, let's say, the most difficulty we have is the wind load, and the wind load is a square function of the altitude of the system. So we would need much more steel, and we need much more grounding if we wanted to build these structures even higher above corn. So that's not really an option. The second one was the question regarding the potential negative effect. To be honest, I didn't really thought about this question regarding the negative temperatures, since indeed you're right, that might be a fact in the Nordic region. What we see is positive effects, let's say, on, for example, on dehydration. That's but there might be also a negative effect. Another effect I haven't told you, which also depends from the, or is depending on the Nordic installation, would be if there is snow, we have a huge advantage from electricity production. That's also a point I should figure out, I think, since we have some installations in Austria, and if there is snow, it's a boost for the system. It's the absolute peak production in the year is in February when there is snow, since we have low temperatures, high efficiency of the modules, and since the efficiency depends on the temperature outside. That's on the one hand, and on the other hand, we have a huge increase in the reflection. The albedo goes up, and the production really, it's really a boost.
Well, it makes sense. And actually, like that's a junction for the next question. We had a question on albedo. Doesn't actually low albedo of crops reduce the PV production?
It depends on the ground, of course. Yeah, is compared to snow, everything is less gives back less irradiation. As we use a lot of Greenland, which has a quite good albedo, which work very well. Maybe might be that some other crops have a lower one. I think their albedo is around 0.1, 0.2, and I think there are not very huge differences between the crops, but there might be some effect.
Okay. Interesting. In the audience, if you have more questions, just keep on going. We will still do some questions for like 3-4 minutes. There are still some in the pipe. Actually, a bit of a far-stretched one, but I think it's a super interesting one. So let me read you this one, Sascha.
Yeah.
Do you imagine the future having a label in supermarkets for food which would have been produced in places where actually like renewable energy is also produced? Just like you've got labels for biofood. I mean, like, do you think, or is your company or like companies with whom you're working with authorities, maybe the EU, this kind of stuff, to develop a label to say, hey, crops produced in a place where we're also producing clean energy, etc. Do you have something like that yet or not in the pipe?
To be honest, I'm really happy about this question, and I have to say I never thought about it before. We thought about the other direction, to label the energy production, that it still allows crop production in between. That's something we already thought about, but it's a quite interesting idea also to look it from the other, take it from the other side, and to say these crops were grown up where also electricity was produced. It's very interesting, very interesting. I didn't thought about that, but we will catch that up.
Well, and then like I'm not allowed to mention names or anything in webinar due to privacy, etc. But so the person who asked this question should like get in touch with you for royalties later on. I think something.
Yeah, I would be very interested. Yeah, great.
That's a nice one. Okay, I still see like 2 more questions here. Let's ask those 2. When you were talking about ecology impact, you had a slide beginning with like no ceiling and almost no overbuilding. But could you explain a bit more what you meant by no ceiling?
No, we have no ceiling on the land. So since it's vertical, all the land is still open. There's nothing built above the land which takes the water away, which takes which would reduce the water coming to the land and all the stuff. So that's what we meant with this point.
Okay, and I guess the question was in relation to the fact that later you're mentioning like you can use it as a sealing area, but like for the chickens or like what other kind of cattle, but it's no sealing underground. Okay.
Yeah, exactly. Yeah.
And then final question, do you have an estimate of what land area is required with this technology per megawatt?
Yeah, it's around. It depends a little bit, also, of course, on module size and efficiency and all this stuff. But what we currently have is, let's say, around 0.4 megawatts per hectare. We could increase by reducing the module row, the distance between the rows, maybe to, let's say, 0.5. And of course, the growth in module efficiency also will increase the installed capacity per hectare.
Okay, well, thanks, Sascha. Like we don't have questions anymore. It's 3:56, so perfect. I'll just thank you very much for your time. Thanks to the whole audience to have been here with us. As you can see on the screen, and again, you will get those slides later. You can see the email of Sascha if you've got some more questions, if you've got ideas to propose to him, these kind of things. Again, like we're doing this event called the Solar Future Nordics on September 23rd in Stockholm. And it's still possible to register. It's a purely physical event. So by this, I mean like it's all of us physically present at the venue. We have like a big space for the amount of people we're expecting. First opportunity for people already doing business in Scandinavia or wanting to do business there in solar energy to connect. Sascha, yes, thanks again. I think like the audience will have learned quite a lot of things. It was really nice to see that almost 90% of the audience was thinking it's indeed like a positive solution. As you said, you've also had additional thoughts coming thanks to some of the audience questions. So I hope everybody's happy, had a constructive and entertaining and instructing hour. And again, well, thanks everybody. Here on the screen, you can still see
from my side. Great.
And yeah, if you want to say something, please go ahead, Sascha. Please.
Yeah, okay. I also wanted to say to thank you for the invitation on the one hand, and the audience for the interesting discussion and ideas.
Well, again, then, thanks everyone. Thanks for your time. Hope to see a lot of you in Stockholm on September 23rd. And until then, well, you know where to reach us. You'll get the slides by email, max by the end of the week. And any question, we're there to help you out. Thank you very much to all. Bye-bye. And we will then close this webinar in just a few seconds. All the best.